Hey guys, welcome to Chemistry Expert. Today I will be teaching valence bond theory. In that we will be covering the hybridization geometries with their examples. Fine guys, let's move on to the salient features of the valence bond theory. Salient features, the first and foremost feature is covalent bonds are formed by the overlapping of empty vacant metal orbitals equal to its coordination number with the ligand orbitals. That is, covalent bond are formed by overlapping of empty vacant metal orbitals. If this is a metal, means it will have the empty metal vacant orbital. No, this vacant orbital are filled by the ligand's electron. So the overlapping of ligand's orbital with the empty vacant metal orbital forms the covalent bond. And the second feature here is the vacant orbitals of central metal ion hybridize, producing equal number of hybrid orbitals of equivalent energy. See guys, if this is a central metal ion's vacant orbitals, this will be combined with new orbitals and it will form hybrid orbitals. This is of equivalent energy. This point explains this thing. And the next feature is the hybrid orbitals are vacant and have definite geometry. So we obtain these hybrid orbitals. No, these hybrid orbitals are vacant and this will have their definite geometry. And these hybrid orbitals can either n-1d or ns or np or nd orbitals for hybridization. And the next feature is in case of d orbitals. In case of d orbitals hybridization, either it involves inner n-1d or outer nd orbitals. In case of n-1d, it will form low spin complex. In case of outer nd, it will form high spin complex. Electrons can be paired under the influence of strong field ligand. If this is the electrons filled in an orbital of d, so under the influence of strong field ligand, these electrons gets pair up and it will form this type of electron. So under the influence of strong field ligand, these unpaired electrons gets pair up. And the next feature is if the complex of unpaired electrons, then it is paramagnetic in nature. Similarly, if it has no unpaired electron, then it is diamagnetic in nature. So the last and foremost is the magnetic momentum is given by spin only formula, that is mu equals to n square root of n into n plus 2 Bohr magneton, where n is the unpaired electron. This and all are salient features of valence bond theory. This you can also say it as characteristics or properties of valence bond theory. So now we'll move on to the coordination number with their hybridization and geometry discussion. See guys, you know what is coordination number. Coordination number is nothing but if it is a metal and this metal is attached with n number of ligands. Usually it is stable in case of 6 coordination number. See, in this case total number of ligands attached is 6. So the ligand attached to a metal, the number of ligands attached to the metal, nothing but coordination number. So in case of 2 coordination number, the geometry will be linear, that is it will be like this. In case of 3, geometry will be linear and the hybridization is kind of SP or PD or SD. In case of 3, the geometry will be SP2 or SD2 and the structure will be trigonal planar. That is metal, ligand, trigonal planar structure. And tetrahedral structure you guys know. Metal, here one ligand. So this is tetrahedral structure. In case of square planar, it will be like this. So this is square planar. And this is octahedral structure for trigonal bipyramidal. Let me erase this and I will write. For trigonal bipyramidal, the structure will be something like it will first form a triangle. And bipyramidal. This you can also write it as this is trigonal bipyramidal. So in the above side one pyramid is formed, in below side one pyramid is formed. So this will resembles the trigonal bipyramidal structure. This in case of coordination number 5. So see, you can see 3, 4, 5. Here 6 coordination number. So in case of coordination number 5, the hybridization will be sp3d, and in case of 6, sp3d2, d2 sp3 or d2 sp3, and the geometry is octahedral. So guys, what and all I have discussed in this video. The first is the Salient features. In the Salient features, I have discussed the covalent bonds are formed by overlapping of empty vacant metal orbitals equal to its coordination number. Then this point, vacant orbitals of central metal ion hybridize, producing equal number of hybrid orbitals of equivalent energy. And the next one is hybrid orbitals are vacant and have definite geometry. And the next is metal atom or ion can use N-1d, Ns, Np and Nd orbitals for hybridization. And this we have in case of d orbitals hybridization, either it involves inner or outer d orbitals. So electrons can be paired under the influence of strong field ligand. If the complex have unpaired electrons, then it is paramagnetic in nature. So the magnetic momentum is given by spin only formula. So this is all of the Salient features. And in this slide we have discussed the coordination number with respect to their hybridization and geometry.